Hey guys, what I'm going to introduce today, I'm just going to be looking at the number of turns in a coil and how that affects the electromagnetic induction. And what I'm doing here is I'm using an old galvanometer here, Sergeant Welch, which is, I kind of like these old instruments because they're really nice. They give you that direction of the current as for Lenz's law that you're dealing with. Now, and you can kind of see here what I have. I have an 800 turn coil. I have a 400 turn coil. And then over here, I have a 200 turn coil. And what I'm going to do is I'm going to first operate with the 800 turn coil here. And we're going to take a look at the galvanometer. So I've got my magnet here, and I'm going to use my north pointer here. And I'm just going to bring this, in front here. And we can kind of see, as Faraday would say, that if we don't have a change in flux, so you'll notice here that the galvanometer here, we have no change here in the galvanometer. So as long as we have the magnetic field is the number of field lines that are cutting through the cross-sectional area are always remaining the same, we're not going to induce. But the minute we change that, and let me do that here. If we move the magnet into the coil like this here, or bring it towards it like so, we're going to get some action on the galvanometer there, as you can see. And we're getting a combination of two things here. So we're not only inducing, but we can see through the galvanometer that the current's changing direction in the coil. And that's kind of what we're getting with that Sergeant Welch. So you can see with the 800 turn coil, we're really getting some nice play on this. So now if we take and we switch this guy here, and we move this into the 400 turn coil here, and we're going to check out what's going to happen with this one now. So we can kind of do the same motion that we were doing here, moving the magnet into the coil, so we can move it in. Sorry about that. A little tighter on the 400 here, I guess. So we can move it in here and check the galvanometer out. And we're not getting as much on the galvanometer. We're still getting pretty good, as we can see there, but not as much as we were getting with the 800. So then we can go down to the 200 and then see if there's a lot more of a drop-off here. And we're going to go over to the 200 here. Sorry about that. And let's see what we got here. And there's the 200 here. And we're going to get the same motion going on there, moving this in and out here. And you can kind of see here with the galvanometer, not nearly as much as what we had with the others too. So we realize that the number of turns is directly proportional to the induced EMF that we're getting. So this is just a little demonstration, guys, that really is dealing with the number of turns in a coil and how that's affecting our induced EMF or our electromagnetic induction. And that's about it, guys. So thank you now.